In the last video, you saw a simple example of an abstract syntax tree, or AST, for the expression 1 plus 1. But most ASTs aren't this simple. For example, here's a slightly more complicated expression, 1 plus 1 times 2. And here's the AST for this expression. Notice there's an AST nested as one of the arguments here for the expression 1 times 2. Here's another example of an AST for the expression 1 plus 1 times 2 minus 1. Okay, now imagine trying to manually create and return ASTs that are shaped like this. I don't know about you, but having to manually generate a nested AST like this doesn't sound like much fun. Luckily, there's a better alternative to manually creating ASTs, which we'll look at right now. Here's the manually created AST we returned from the reverse function in the last video. But here's the thing. I don't want to have to create this tuple, or even worse, I'd really hate having to create a deeply nested tuple that looks like this. And we can avoid this by using the quote macro. So what does the quote macro do? Well, let me show you in IEX. I'll use the quote macro, which can either be used with a do block or a do keyword, and I'll pass in the expression 1 plus 1. Notice what the quote macro returns when I press enter. It returns an AST for the expression we provided it. So do you see where I'm going with this? What I mean is, do you see how using the quote macro might come in handy when you need to generate an AST? Let me show you a more complicated example. I'll use the quote macro with the expression 1 plus 1 times 2 minus 1. Here's what I want you to take away from this more complicated example. It's pretty darn easy to write this expression in normal code, but the AST behind this expression, which you see right here, is a bit daunting, and having to create this by hand would really suck. So instead of manually creating ASTs like we did here, why don't we just use the quote macro instead? For example, I'll comment out the manually created tuple, and we'll create a quote block. Then I'll simply put in the expression a minus b. Now, in theory, this quote block with this expression will return an AST that looks just like this one, but we don't have to think about and work with ASTs directly. Let's see if this actually works. So I'll open up IEX, and I'll require the util module. Then I'll call the reverse macro, passing in the expression 1 plus 1, and we got an error. Now, error messages in macros can be challenging at times, but if you look at this part right here, it seems like our macro thinks that a is a function. But if you look, a is a variable that should be bound to the number 1 in this example. So what exactly is happening here? Well, let me give you a better demonstration of the problem right here in IEX. I'll start by creating two variables, a, which I'll bind to the number 1, and b, which I'll bind to the number 2. Now I'll use the quote macro again, and I'll pass in the expression a plus b. So is this what you expected the AST to look like? Or were you expecting the AST to look more like this one, where the arguments are the values 1 and 2 that you can see right here? What happened in this first case is that the 3-element tuples were created for the variables a and b. It didn't actually use the values that the variables a and b are bound to. The same thing is happening in our reverse function. The AST returned from the quote macro looked like this, when in reality we wanted it to look like this. Then, when this AST was evaluated, it tried to call a function named a in the current context, and of course there is no function named a, so it threw an error. Alright, so how do we fix this? Well, there's another macro that goes hand in hand with the quote macro, and it's the unquote macro. Here's how you use the unquote macro. I'll call quote again, but this time I'll pass in the expression unquote a plus unquote b, and notice this time the AST returned from quote includes the literal values that were bound to the variables a and b. Okay, so let's fix the reverse macro by unquoting A and B. Basically, this unquoting is injecting the values that A and B are bound to into the returned AST instead of just throwing the identifiers A and B into the returned AST. Using unquote is kind of like string interpolation. Well, not exactly, but it's kind of similar. Okay, I'll recompile our module, and I'll run reverse again, this time passing in the expression 5 plus 10, and the result is -5, which is what you'd expect. Okay, I'd like to create a more interesting macro, and that's what we'll work on in the next video.